when we're looking at this diagram, the first mistake everybody's making is this this force right here. They don't know what to do with that. So let's handle that from the beginning, because that's the one that doesn't fit any of your categories, right? We have a bunch of categories for forces. That one doesn't fit. It's just there. So if you have a force that doesn't fit, that's just there, just put it there. You have no choice. But you've got to make decisions like, what do I do? Where does that go? Those are some hard choices to make. So let's leave that one till the end. Is that okay? And deal with the obvious ones. Now, I go in order, and I try to go the same order every time, so that I believe that a little bit of repetition helps you build, kind of that practiced mind. So you're going to draw a downwards arrow for gravity every time. That's always going to happen. So I tend to try and start there, because it's the one that I know you can get right. Yeah, is that terrible? But it's the one you can get right. Now, the normal force, and I didn't realize, as a teacher, you don't always realize where students are going to have trouble until it happens. And so students that had trouble with stuff years ago, that's what I'm prepared for. But students are having trouble with the normal force this year, and I didn't know. Part of it is, what is happening here? Part of it is, I didn't realize that I have a whole crop of kids who don't know what this word means. I just assumed, because that had not been a problem before. But normal means perpendicular. The problem is, I met a student 2 weeks ago who didn't know what the word perpendicular meant. All right, that's fine. If I had known that a month ago, I probably would have done things different. But I didn't. So, and you're out there, and when I mean you're out there, there's somebody else who doesn't know what that word means. What do I do? Because I didn't know, and nobody brought it to my attention, because I think it's because I'm Mr. Shelton and people are scared of me. So perpendicular means a right angle. That's all it means. So this is easier said this way. If I just get up right to the board, this is the wall. So a normal force has to be perpendicular to the surface. So you have to find the surface. If this is the wall, then the normal force has to be at a right angle to the wall. That kind of gives you two choices then, right? It's either this way or it's this way. And that's still a 50-50 shot, but it can't just be any way. So what I'm saying to you is that you're either going to draw your arrow to the right or to the left, one or the other. So I tend to come at it now that I know this and think, okay, if this situation were this, where I'm taking this box and I'm trying to hold it against the wall, there's a part of me who's pushing. I'm the F, right? I'm the force that's pushing against the wall. The wall's trying to keep the box from going through the wall, right? If the wall didn't apply a force, then the box would just go that direction. It would pass through the wall. So what direction does the wall have to push to keep the box from going through? Well, it's got to push back on me, right? It's got to prevent the box from going through the wall. So as I'm trying to choose what direction I need to draw this arrow, what direction would the wall press to keep the box from going to the right? It would have to be to the left. So the normal force, and this is true for every surface. And I saw it on the test the quiz before, where I put the box on the surface, or put the box on the ceiling. I had people who drew the force from the ceiling in the wrong direction. But it's going to try and keep the box from going through the wall. Now, the next question is a little bit harder. It says a box of mass m is being pushed along a wall with a constant force at angle theta. The box moves up the wall at a constant velocity. This situation is balanced because it says the words constant velocity. And I have this force. Now, to deal with that force, I kind of said we would deal with it at the end here. And I'm not sure we're at the end, but I think we're getting close. I don't want to move that. I want that to stay locked. How do I? There. I want you. Why is that not working the way I want? I don't know. You'd think I'd figure out my tech a little bit better, but apparently not. There. So what you want to do with the force like this is you want to push it through so it can be on the center of the object. So I tried to set it up so I could push it through so it could be at the center of the object. But what I'm really going to do is I'm going to take it off and put it over there. So now it's starting from the center of the object and is going outwards, because all the forces on a free body diagram have to be pushed away from the center. So I'm just trying to cut and paste it over there, but I have to deal with this in a meaningful way. And to do that, I'm just kind of continuing the two lines in my head to know that this has to also be theta because of the vertical angle theorem from geometry. It's not something I taught you. It's something that somebody else taught you probably several years ago. I just assume you have it, but you may not. Yeah.
How do you know if it's on the wire or something? So, I mean, like with the angle?
Well, right now I don't know. All I did, because I haven't drawn my coordinate system, so what I did was I hearkened back to my recollection of geometry, which said that if I have any two lines that cross, I know that these angles are congruent and these angles are congruent. So based on that, which was from geometry, I just continued the two lines that were put there for reference. And that kind of helps me figure out that if the angle was down here, well, if I continue this line this way, that angle should be right there. Because it would be as if these two lines, because that would be the old theta. Does that make sense? So that gets me my force. The question I have to ask is friction acting in this problem? They don't say anything about it, but they do say that the box moves up the wall at a constant velocity. So if there was friction, and I'm saying if, I haven't read the problem very closely yet, if there was friction would have to act this way. Because it would have to act along the surface, for one. It has to be perpendicular to the normal force, or at a right angle to the normal force, for two. So it has to try and oppose the motion of the box, and the box is going up the wall, so friction should be down. Now, again, I don't know if I'm supposed to put friction in there or not. I didn't read the problem very closely. So I guess I should read the problem closely. Assuming there is a frictional force, I see that in part C, so probably I should include friction. Now, I can tell you I wrote this test last year. If I was to rewrite it this year, I probably would say in the description that there was friction. I wouldn't want you to read into the weeds to see that friction existed because you've got all the way down to part C. Last year I had different thoughts about that, but this year I realized I probably just need to be pretty plain from the beginning. So it was a conscious choice last year to make you try and read the whole problem first. I just want you to know that. This year, I'm going to put all of that in the descriptor for the test. Does that make sense? It's just a difference in philosophy for me this year. I think that's a complete free body diagram. Are there any questions about it? Now, on the AP exam, you can't do anything else to it. You have to leave it there. On my exam, I will probably let you do work, in that box. So let's go on to part B. Find an expression for the normal force acting on the box in terms of m theta f and any fundamental constants. I believe that you will have to do that kind of work on your test tomorrow. Yeah?
When this is like into direction in the diagram, does that mean like it will allow you to do like plus y minus y plus x like make the grid, or?
Yeah. I'm asking to see your choices for positive and negative. Does that answer your question?
Yeah, because I was just wondering like on the exam, they were like thinking about A2 would let us draw the grid out, or would they like tell us not to?
How about I give you an example of what the exam looks like? That might answer your question better. So I want you to have a certain amount of freedom to make some of the decisions yourself, because that will serve you better. So when I say put a coordinate system in, one of the things I will be looking for, you won't receive a point for it here, but an indication of positive and negative, so that when you structure your net force in the x direction and net force in the y direction equations, one of the things I will be grading is what do you put in each of these, what's been made positive and what's been made negative. I don't care if you made to the right positive or to the left positive. I care that when you take this force and you break it up into two components, I'm not going to do the trig, just F in the y direction and F in the x direction. When you break it up into its two components, you make this component positive because it points in the same direction as the positive sign, and you make this force negative because it points in the negative direction. So I would see F in the x direction minus normal equals 0. I'd see it clearly that you've taken into account direction. So I won't care that in the case of this problem you made to the right positive. I will care that you applied positive in the direction you indicated. Is that I'm trying to be as clear as possible. Yeah, because what's going to happen when you have your test is there's going to be 4 points for this free body diagram because there are 4 arrows. So you get 1 point for each arrow drawn correctly. You won't get a point for the coordinate system necessarily, but you will get a point because you subtracted the normal force from the horizontal force, right? So there'll be a point for putting the forces together in an equation and making the things positive and negative as indicated on your diagram. So there'll be 2 points here. Does that make sense? Okay. And then there'll be another 2 points or 3 points for the next one, because this is going to be F in the y direction minus weight minus friction equals 0. Yeah.
Is it fine if you put the angle like where that F is?
Is it fine if you put the angle where the F is? Here?
No, like on the other side of the line.
Here.
No, like
Just tell me, I don't know, I'm trying.
on the right side of the line, but like above.
Those angles would be the same, right? They are alternate interior angles from geometry. Mathematically, everything's going to be the same. I really wouldn't do it if I were you. I'll have to go and read one of the table reads. A table read is what the head leader at the table that read the AP exams, I have to read what they said for about how you deal with reference, because it's a little bit outside the boundaries. The standard way to do this is to have all of your angles relative to the central coordinate system. There's good reason for that, because in the future there might be situations in which you're going to transform things, like shift your coordinate system by this many degrees. And therefore, if you put it over here, that won't work. So there's a future where you might do that in a problem, but I don't know that in this class where it's simpler, where that'll ever matter. Is that okay? All right. We're going to have to move faster than this, but yes.
For fx and fy, is it okay if we put like f cosine theta?
Oh, yeah. I just know that I have somebody in the room who's still struggling with trig.
But either one works for the final answer?
No, to be honest with you, fx would not be okay. I would really want this to be f sine theta in the long term. But the way I'm going to grade tomorrow's test, because this is a stopgap test, it's to see if you're acclimating to this. There will be points issued for having components there, even if you get the components wrong. And there'll be a separate point issued for doing your trigonometry correct. Do you follow what I'm saying?
Which is better to put f sine theta.
Yeah, if you skip those, if you don't have, like, I would never list out the triangle and do the trig separately, because I don't have to anymore. But I will have kids who are going to have a triangle off to the side where they have sine and cosine written out. For this test, doing the trig and getting it wrong isn't a deal breaker, but you're going to not get 100% for it. But instead of having it knock out everything, I give separate points for trig on this test, but not the next one. Yes, ma'am.
Are we just going to make numbers on the test, or just
There will be at least one question that's all letters and one question that's numbers.
and then how do you even do like the coefficient?
I'm trying to get there. I promise. I will try and get there. But like even Amir has his hand up now. He's going to ask some other question that's going to prevent us from going forward.
Simple question.
I doubt it.
Isn't F sine of theta, but is mg in front of the sine when it's an acceleration problem? Or is mg sine with the angle? When is that the case?
See what I mean? It's completely distracted off of this problem.
Oh, that's
mg would only be in front of the sine if the weight was having to be broken up into components. But I don't have to break the weight up into components because it's all in the y direction. Does that make sense? So we're going to turn this on to turbo mode, F cos theta. There will be another point given for replacing weight with mg. That's a point all on its own. So all of those things are different little things that have to be done. Each one of them assigns a point to the problem. Yes, sir?
If you finish it in your next class, can you post it on campus, please?
Yeah, I can. So what we've done actually solves B and probably solves another one, but the answer to B was just normal force equals F sine theta. When I go to C, it says assume there's a frictional force acts in the box, find the expression for the size of the frictional force in terms of all those things. We can do that right now because we have net force in the y direction completed. So we can solve for that answer, C. So that would just be solving this for F. So F equals F cosine theta minus mg. Now, this is just algebra, but I know some of you still struggle with algebra. I'm going on to D now, because that was what was asked for next. Find an expression for the coefficient of kinetic friction. I won't say that because we really haven't developed that concept as far as I thought we would by now. But the coefficient of kinetic friction, I would replace this with find the ratio of the frictional force to the normal force. That's what I will say. I will expect that you know what ratio means. So D would be friction to normal force, or F cosine theta minus mg over F sine theta. That is the coefficient of friction. But we just barely scratched that surface, so we're not there yet. So I will phrase D slightly different than how it's phrased here. Yep.
So then what about the F equals
What about the F equals
MA?
MA?
Like the one from yesterday. I thought that would be the way you said. I thought that was the
No.
No?
No, the coefficient of friction is what percentage of the normal force is friction. Whether one of these equals MA or not doesn't change that. Okay.
I didn't say MA, I said the F with the weird M.
Oh,
Yeah,
mu.
Yeah.
Yeah, that's what that would be.
Oh, okay.
Yeah, if in the future I won't even say coefficient of kinetic friction, I'll say solve for mu.
Oh, okay.
But we're not there yet. This is still
Okay.
baby steps. Okay, how would the problem be different if the box were sliding down the wall instead of up? I'm looking for a sentence descriptor here. And all you would really need to indicate is that the frictional force would point upwards instead of downwards. So it would change the sign of the frictional force. I mean, ultimately, it would make this a plus sign and not a minus sign. That has implications all along the problem. It means these two would be the opposite. It'd be mg minus F cosine theta. But it would be a written description I'd be looking for here. All right, wow, that's a lot. But good questions. Thank you all very much. Are we on schedule? So there will be an inclined plane problem. There's absolutely no doubt there'll be an inclined plane problem. We didn't finish this one. I'm sure I will start with this one in second period, but I'll also be available tonight for tutoring. So I'm feeling real. Is salty still a word? Can I say that? What would be the new word to replace like I'm feeling salty? I'm feeling sore? Sword? With a D?
No.
Like sore like I worked out too much? Oh.
But that, I'm not calling you a leader. I'm just saying like that would be.
So what if I'm not a sore loser?
No, that's what I'm saying. It's not about like losing. I'm just saying.
What did I lose?
I don't know.
Be careful. I'll be intimidating.
I'm thinking.
Don't make me be intimidating. All right. Mr. Sheldon, sore loser. All right. A box. Yeah, there's always some stupid box. 20 kilograms sitting on a thing. The incline is raised so much where the box slides down, blah, blah, blah. Draw a free body diagram for the block in the box provided. All right. So I should make you guys, oh, by the way, I have bought stuff, so I can just put the iPad in your hands and you guys do it. I've waited till second semester, but I've got 2 other iPads now. So from now on, I can say, here, you do it. The Chromebooks all do it too. I haven't told you that, but they can all connect right in. So your future is a Chromebook on your table or one of my iPads on your table, and I say, go ahead, Leah, it's your turn. Start drawing me arrows, and the whole class gets to watch. It's so fun. I'm so excited. So keep that in mind. All right, but for now, I'll do it. Draw a free body diagram for the block in the box provided. This one it's a inclined plane. And although there are things in this practice test we have not yet covered, everything we're going to do here is something I will expect on the test. And every one of these questions, if phrased correctly, is something that you can do on the test. I would start by drawing the weight. Now, we know this is 200 newtons. Somebody asked, is there going to be numbers on the test? One of your FRQs will be numerical. One of your FRQs will be all algebraic. This was a numerical one. There's another force, and it's the normal force. And I've had some trouble with students in the normal force because I thought saying the word normal would be enough. It's not. So then a couple years later, I started reminding them that when they were in another class, they learned that normal means perpendicular. You know what I found out this year? They don't know that perpendicular means 90 degrees. So now I've used them all. If you're the person who didn't know that perpendicular meant 90 degrees, and I know you're in the room, you don't have to out yourself. But look, if I say a word and you don't know what it means, it's okay to say, Mr. Sheldon, I don't know what that word means. Now, if you think you're going to sound stupid doing it, imagine how you're going to sound 3 weeks later saying it to me. I didn't know the word perpendicular meant that. You've been using it for 3 weeks. Do you really understand how that makes you look? So just ask, or better yet, Google. You'll Google anything else. So I mean perpendicular, I mean it's a 90 degrees to the surface. Now, that offers you options. That's 90 degrees to the surface, and that's 90 degrees to the surface. And you have to know that this is the surface we're talking about. Which one is it? Well, what direction does the incline push? It's a pushing force. It has to be the upwards one. It has to come away from the surface. It can't go into the surface. So the surface isn't pulling on the object. So, and I'm being a bit facetious, but not as much as you might think. So draw that, normal force. Now they tell me the box is accelerating, but I have to read down further to realize that there's a frictional force acting. That was a purposeful decision last year to tell the kids to make sure they read the whole problem first before they began. I'm not sure I'm going to do that this year. I've not finished writing tomorrow's test. I have most of it written out, but I might redo the directions so that I just say in the directions whether you have a frictional force or not, and not leave it to be ambiguous. So no guarantees, but that's likely to be the case. So friction has to be drawn so that it is 90 degrees to the normal force, which means it could be drawn in this way or this way. But we have an answer to which one of those it has to be. If the box is sliding down the ramp, friction opposes the motion of the box. So it's got to be this one. It's got to be up the ramp to try and prevent the box from sliding down the ramp. So that's the direction of friction. That is the free body diagram. On an AP exam, right now, this would be worth 3 points, maybe 4. On the ap1 exam, they'll probably reduce it to 2 if this is a 7-point question. And sometimes only 1. Yeah?
Could you explain again why friction force is a smaller term?
The box is accelerating. So I know that the frictional force needs to be less than the force dragging it down the ramp. In fact, I probably drew the frictional force too big because the force dragging it down the ramp is going to be a part of that force, right? A part of it. So I know it has to be smaller than the weight, but more importantly, I know I'm thinking of the future. So this is not right now, but there will be a coordinate system here like that. This is the part of the weight that's down the ramp. Friction actually should be smaller than that, so it can accelerate down the ramp, right? It says it's accelerating down the ramp. Actually, I'm not sure it says it's, yeah, box slides down the ramp. It doesn't say whether it's speeding up or slowing down. That's ambiguous. You guys see that? So that's a teacher problem, not a student problem. Don't, tomorrow, if you think it's ambiguous, ask whether it's accelerating down the ramp. Like, you can ask me if it's speeding up or slowing down. Does that make sense? I should make it in the problem explicit so you know. But if I don't, ask, because I'm not trying to make you guess on that. Does everybody understand? I'm not trying to make you find out whether it is or not. This is our first test on force. I'm trying to see if you got the basics down. Does everybody understand? All right. And even last year, I probably told students whether it was speeding up or slowing down. So technically, I would expect you to leave this here and then do your work somewhere else. Yes, ma'am? You're going to speak too quietly and I'm deaf. I'm going to need you to project from the diaphragm.
Okay. So you said that when you're trying to make the angle to always make the line going all the way through the normal force and
Yes.
so does that mean to always align the brake system with the normal force?
Boy, I hate the word always, but for an inclined plane, yes. Now, I'm saying that knowing in my head that you have to know when to break those rules, which is why I gave you a set of rules to tell you how to do this. So if you use the rules I gave you, it will almost always work out anyways. I said to line up the coordinate system in the direction of the acceleration, or so that it lines up with as many forces as possible, and that will still serve the function we described. Does that make sense? So I think if you use that as your always, you'll be in better shape. Because it should always work out then that you'll be able to draw the angle in correctly. Yeah?
For the free body diagram, would it be wrong if you were to call it equal to a line?
I don't understand the question. Do you have a picture in front of you that I could look at?
Yeah.
She's already drawn in this force and listed as a force and did mg cosine theta and then drew a force this way and called it mg sine theta and did not draw that. That is going to be what we are going to end up with. But that would not be considered the free body diagram because it lists components. It doesn't list the actual forces. So this is the future of this question, for sure. But do you guys understand why I'm saying that? On the actual exam, when they want a free body diagram, the points awarded will be for forces. So they'll actually, you would lose 1 out of 3 possible points if it was 1 point per force. This is an easy 3 points, I think. Now, if there's a box like this and I say only put a free body diagram in the box, someplace else you should do your work. I'm not going to do that in the interest of time, although I've been wasting quite a bit of it. So let's get moving on it. What is the problem here? Mr. Sheldon. So I'm trying to draw my coordinate system. I aligned it with the direction of the acceleration first. I made this the positive x direction. I'm making this the positive y direction. And yeah, if I extend the normal force down to over here, this has to be the angle. So that's got to be my 30 degrees. And now I have a complete coordinate system, and it is drawn with respect to the forces that are there. Yep.
We draw our coordinate system on our motion map, like in that box.
I can't remember what I said on your test that I wrote, because I wrote the test like a month ago. So I believe I say that you can work on it. No, I think I put 2 boxes on your test.
Oh, yeah.
One box that has a free body diagram and no coordinate system or components, and one for you to do work in. So I'm pretty sure that's what I did, so that you would be clearly delineating it. Does that make sense? Where one of them, use rulers, make it nice, and the other one, I don't care, it's just for your work. Does that make sense? Okay. But like what I'm doing right now would be in that second box. Like, all I would want is everything that's not red there. Okay? Yeah.
Slightly stupid question, but how do you decide?
Well, because I just answered it. That's all. Here's what I would do. Okay? Once you've lined up the y-axis with the normal force, once you've done that, like I drew the red line, extend in your head the normal force down onto this side. Can you guys see that little red dot I'm bouncing over there? And once you've done that, I'm telling you that the angle of the incline is between this line and this line. So you extend the normal force down, and the angle has to be in this side between the y-axis and the weight. Okay, that's how you know. And you will always get it right if you do that. Yes?
What if you like forgot to do that and instead extended the weight up and put the angle between the normal force and the weight extended up? Would it essentially be the same?
This angle will definitely be 30 degrees, but if you're breaking the normal force up into its components, you've probably got your system aligned wrong. So the only force that has to be broken up into components is the one that's not lined up with one of the axes. So this one has to be broken up in components because we don't know how much of it's in the x direction and how much is in the y direction, because it points to both. The other two forces, the frictional force and the normal force, all point in one dimension. Our job is to make whatever force is not pointed in the x or y, that's when we have to break up into x parts and y parts, because our math can only handle one dimension at a time. Does that make sense? All right. All right, so if I don't look up, there are no questions, so I can move on. I'll just keep looking down. Shrek, I'm looking down. So I drew my triangle around the angle, and this will be 200 cosine 30. And this will be 200 sine 30. I'm leaving out the trig, but just so you guys are aware, when I look at points later, in a few minutes, I know we're going to do net force in the x direction and net force in the y direction. Actually, I don't know that. I haven't really read the question, but I'm analyzing the problem anyways. And I think it's going to accelerate in the x direction, but not in the y direction. In fact, I set it up to do that, right? I drew the x direction in the direction of the acceleration on purpose so I could split those up. And now, in the x direction, I have this force and this force. One of them is positive. 200 sine 30 points in the positive x direction, so the friction must point in the negative x direction, and they equal ma. This part's, if you're looking for points, I'm going to give points for summing up all the forces and taking into account their direction, which means there's probably 2 points for putting something to represent the weight in the x direction and something to indicate the friction. So 1 point for listing those forces, and then 1 point for ensuring that you chose direction, which means you made one of them positive and one of them negative. That's where those 2 points will come from. But there will be a separate point for putting 200 sine 30 for the weight. So meaning a separate point is going to be issued for doing your trig correctly. Does that make sense? Now I don't need to see the trig. If you wrote 200 sine 30 there, you're going to get that point. Yes?
So if you had put like mg sine theta, you wouldn't get the point.
No, you would get the point.
Oh, okay, so it's not about the numbers.
No, it's not about the numbers. It's about making sure you do trig correctly. The truth is, I would, if I were doing this problem myself, I wouldn't put any number in until the very end.
Yeah, because that's what I do.
Right, that's what I do. Good way to do it. So, moving on. So I have normal minus 200 cosine 30 here. They equal 0. This would also probably be worth 1 or 2 points total. You would not receive the trig point here. 1 point for both components is how the trig will work. Because basically, you know if you flip them, they're both wrong. So you're not penalized twice, but you're also not rewarded twice. Does that make sense?
Yeah.
1 point for your trig. I really don't know what the question asks, but I know now I could figure out the frictional force. I have enough information to do so. And I know I can figure out the normal force. I have enough information to do so. So whether or not the problem asks for that, I have all the numbers here. I could figure out F. And I have all the numbers here. I can figure out N. Yes, sir?
I don't know which planes accelerating on, which planes
It's accelerating down the ramp. Is that what you're asking? So this problem looks like this. Except faster. And it's slowing down, not speeding up. Right? This problem suggests it's speeding up down the ramp. So I could do that. You're ready for pain. Right? That's that. That's what it is. Why wouldn't it what? Because the x direction's that way, so the y direction's this way. It's not accelerating this way or this way. It's accelerating that way. Does that make sense? I have aligned the x direction to be perpendicular to this ramp. Is that okay? Yes. Mass times acceleration. So, I don't even know what the, all right, here. Find the size of the frictional force acting on the box. That's this one. So let's find the size of the frictional force acting on the box. To satisfy you guys, I'll write everything in place. All right, those are all the values that were given. The box is 20 kilograms, the acceleration was 2, the angle was 30. So mg was 200. So this suggests 100 minus 40 equals the frictional force. So the frictional force is 60 newtons. Without the units, it'll be wrong. Find the size of the coefficient of friction between the box and the ramp. I will not ask that question tomorrow. We haven't developed that topic enough. I could say, find the ratio of the frictional force to the normal force. They are the same question. So that would be what you will likely see tomorrow. So I'm going to do that. Next test, you will have to know that that ratio is the coefficient of friction. Everybody understand? So I'm making that very clear here. This is the last time I will not use the words coefficient of friction. They've been introduced in class. I should be using them. I'll cut you a break tomorrow. Better check the test. But the only way I can do that is if I know the normal force. So I have to figure out the normal forces first. So, since everybody's trying to see around everybody's shoulders back there, let me make it smaller, move it a little bit higher. So the normal force is equal to 200 cosine 30 degrees. Cosine 30 is 0.866. So 200 times cosine of 30 is, I don't know, 160 something?
173.
100 what?
73.
173. Not terrible. In my head, kind of work. So that's not the answer. The answer is to take the 60 and divide by 173, and this is your answer. Whatever it is, about a third.
Yeah.
It's a unitless quantity. It's newtons divided by newtons, so there's no units in this quantity. D, consider a different arrangement where the angle of the ramp is steeper, but there is a coefficient of static friction that is smaller than currently. A cable is attached to the block so that a force can be applied to the block. If you are to determine the force that must be used to hold the block in place, in a clear, coherent paragraph-length response, explain why there isn't just one force that would be able to hold the box in place. There's a lot of ways that you can make this argument. Bless you. The problem is that, again, I'm not sure we have developed this topic sufficiently for this to be the way the question would be asked. So if I were to augment it a little bit, I just wouldn't talk about what type of friction it is. I would say that the angle is increased, which would ensure that you know that the box is experiencing a stronger frictional force. No, the box is experiencing a stronger weight down the ramp and would likely accelerate more. So tension would be required to hold the box in place. But you would have to explain that it's not just the tension holding the box in place. That the tension contributes to it because friction is also trying to hold the box in place. But you should also say that friction depends on the normal force. And the normal force depends on the weight. So all of these forces work together to hold the box in place. Because there's a relationship between all of them. Again, friction depends on normal in this problem, and normal depends on weight. So you would have to include a chain that included all of those forces in your discussion.